Hello everyone, my name is Zhang Junhao and my mission number is 21863. Today I will present my project, Smart Waste Management System. This project is related to IoT communication technology. The main purpose of the system is to monitor rubbish bins in real time and make waste collection smarter, faster, and more efficient. In many public areas, waste bins are still checked manually. This method is simple but isn't always efficient. Therefore, this project introduced a smart system that can help users or waste collection workers know the bin status without checking the bin one by one. A smart waste management system is an IoT-based system used to monitor the waste level inside a dustbin. It uses sensors, a microcontroller, and a wireless communication network to send real-time data to users or waste collection workers. In this system, the sensor is placed inside or on top of the rubbish bin. It detects how many waste is inside the bin. Then the microcontroller processes the sensor data and sends the information through Wi-Fi or LoRa. The data can be displayed on a mobile app or dashboard. Because of this, workers can clearly know which bin is almost full and which bin does not need collection yet. This can make the whole waste collection process more organized and efficient. The picture in the right side shows the steps. So the problem statement: traditional waste collection depends on workers to check rubbish bins manually. This takes time and requires more manpower, especially in large areas such as school, parks, malls, and residential areas. For example, in a university or shopping mall, there may be many rubbish bins in different locations. Workers may need to walk around and check each bin. This is not only time consuming but also tiring. Another problem is overflow. Some rubbish bins may become full before the scheduled collection time. When bins overflow, they can use they can cause bad smell, pollution, and a healthy environment for the community. Overflowing rubbish bins can also make public place look dirty and uncomfortable. At the same time, sometimes waste trucks collect bins that are not full yet. This wastes full time and the labor cost. It also makes the waste collection process less efficient. Therefore, a smart monitoring system is needed to solve these problems. For the system overview, the system works in three main steps: waste level detection, data processing, and data transmission. First, the sensor detects the distance between the sensor and the waste surface. When the rubbish bin is empty, the distance is larger. When the bin becomes full, the distance becomes smaller. Based on this distance, the system can estimate the waste level percentage. Second, the ESP32 or Arduino receiver receives the sensor data and processes it. The microcontroller acts like the brain of the system. It calculates whether the bin is empty, half full, or almost full. Third, when the bin is almost full, the data is sent through Wi-Fi or LoRa to the cloud or mobile app. Then users or waste collection workers can check the real-time bin status and take action quickly. This technical diagram shows the full working flow of the system. First, the ultrasonic sensor measures the gas level inside the bin. The sensor collects distance data and sends it to the ESP32 or Arduino. Next, the ESP32 or Arduino processes the data and calculates the bin level. After this, the Wi-Fi or LoRa module sends the information to the cloud or IoT platform. Then the data is displayed on a mobile app or dashboard. The waste collection team can check the dashboard and decide which bin should be collected first. This flow is important because it helps reduce unnecessary collection. Workers do not need to check every bin manually. They only need to focus on the bins that are almost full. This saves time and manpower. There are several important components in this system. First component is the ultrasonic sensor. It is used to detect the gas level inside the bin. It measures the distance between the sensor and the rubbish surface. The second is the ESP32 or Arduino. It receives the sensor data and controls the whole system. ESP32 is useful because it already has Wi-Fi function, so it is suitable for the IoT projects. The third component is the Wi-Fi or LoRa module. It sends data wirelessly to the cloud. Wi-Fi is suitable for areas with internet connection, while LoRa is useful for long-distance communication. The fourth is the LED or buzzer. It gives warning when the bin is almost full. For example, the LED can turn on or the buzzer can make sound to alert users. The fifth is the cloud or mobile app. It displays the real-time bin status. Users can check the gas level easily through the app or dashboard. Finally, the power supply provides electricity to the whole system. Without a stable power supply, the system cannot work properly. All these components work together to create a complete smart waste monitoring system. Next part is application. This system can be applied in many places. First, it can be used in school and university. These places usually have many students and staff, so waste bin can become full quickly. Smart monitoring can help cleaners manage waste more effectively. Second, it can be used in residential areas. In housing areas, rubbish bins are used every day. This system can help workers collect waste only when needed. Third, it can be used in shopping malls. Malls have many visitors, especially during weekends and holidays. Smart bins can help maintain a clean environment. Fourth, it can be used in hospitals. Hospitals need a clean and healthy environment, so waste management is very important. Finally, the system can be used in smart cities. It supports digital management and helps the city become cleaner, healthier, and more efficient. For the impact, this project has several important impacts. First, the impact to me is that this project helped me understand how IoT communication system work in real life. I can learn how sensors, microcontrollers, wireless networks, and cloud platform connect together to solve daily problems. It also helps me understand the relationship between hardware and software. Second is the impact to the community is that this This system can reduce overflowing rubbish bin, bad smell, and pollution. It can make public areas such as schools, parks, and others cleaner and healthier. A clean environment can also improve people's comfort and quality of life. Third, the impact to the country is that smart waste management supports smart city development. It can reduce waste collection costs, improve public health, and support sustainable development. Overall, this project shows the technology can be used not only for convenience, but also for environmental protection. Here is the conclusion. In conclusion, the smart waste management system is useful IoT communication system. It can monitor bin status in real time, reduce manual checking, and improve waste collection efficiency. This system solves several problems in traditional waste collection, such as manual checking, overflowing bins, and inefficient collection. By using sensors, microcontrollers, wireless communication, and cloud platform, the system can provide real-time information to users and waste collection workers. This project also shows how communication technology can solve real-time problems. It has created a cleaner environment and supports the development of smart cities. So this is all of my presentation. Thank you for watching and listening.